Hello, welcome. This is the Chapter 5 Mechanics Year 2 video on practice for forces and friction. So important things to be able to do here are to be able to resolve a force. So you should be given a vector for a force. You should be able to resolve it in any direction and work out what its component is in that direction. And you should know Newton's second law, which is F equals ma. So those are two important prerequisites. Okay, so question 1. Find the magnitude and direction of the resultant R of perpendicular component forces of magnitude 3 newtons and 2 newtons as shown in this diagram. So in this case, we have two components and we want to work out what the resultant is. So if you imagine a triangle with one length 3, the other length 2, an angle theta, we want to work out R and theta. So by Pythagoras, the result of these two forces, because they're perpendicular to each other, is going to be 3 squared plus 2 squared square rooted. So it's going to be root 13 newtons. And then the angle is going to be inverse tan of the opposite over the adjacent, so 2 over 3, which is going to be inverse tan of 2/3, which is about 33.69 degrees. Okay, and then part B is in the opposite direction, which is the more useful really. So we want to resolve the 10 Newton force, which is acting at 30 degrees to the horizontal, into component perpendicular forces x and y, which are horizontal and vertical, of course. So in this case, we want to work out the components of the 10 Newton force horizontally and the 10 Newton force vertically. And what you should really almost learn by heart, you can work out from SOHCAHTOA, is that the component in the x direction, because it makes an angle of 30 with a 10 Newton force, will be 10 cos 30. Cos of 30 is root 3 over 2, so that's 5 root 3 newtons. And the component which is perpendicular to the direction given by the angle is 10 sine 30. And sine of 30 is a half, so it'll be 5 newtons. So you should become very practiced at being able to do this with any force. Friction. So the coefficient of friction between a body A of mass 3 kilograms and rough ground is mu equal to 0.8. Okay, this gives you a ratio between the normal contact force and the maximum frictional force. And remember, frictional force acts to resist possible motion or actual motion. So body A is in limiting equilibrium. What does that mean? Equilibrium means it's not, it means the forces are balanced. And in this case, because it's static, it's not moving, it will remain not moving. It could be in equilibrium and moving, but that would just mean that you're not accelerating. But in this case, if it's still and you're in equilibrium, you continue to be still. Limiting equilibrium means that you're on the edge of starting to move. So your frictional force is not just a frictional force, it's the maximum frictional force, because we're at the point of moving. So this P, if you imagine, is increasing, and it increases to a point where it's your object is not moving, but the frictional force which opposes it is having to be at its maximum. And that is what limiting equilibrium is in this case. Find the maximum frictional force and the magnitude of P. Okay, so what is this pulling force and what is the maximum frictional force? Well, because it's in equilibrium, we know we can resolve in any direction and the resultant force will be 0. And of course, if we were doing moments, we could take moments up at any point and the total turn effect would be 0. But in this case, we don't need moments because we're treating this as a particle. So if we resolve vertically, we have the only forces that have components vertically are R and 3G. So R minus 3G equals 0, and so R equals 3G. So that's nice and easy. And then if we resolve horizontally, P minus F equals 0, and so P equals F. Now, if F is maximal because we're in limiting equilibrium, that means that F equals mu R. Mu, we're told, is 0.8. So that means the maximum frictional force is 0.8 times 3G, which is 2.4 G. Okay, and notice that the coefficient of this force, the ratio of this force to this force is 0.8. And that's exactly what the coefficient of friction is. So if you increase the contact force by maybe pressing down or increasing the weight, then the maximum frictional force would increase for the same coefficient of friction. The higher the coefficient of friction, the stickier, if you like, is the object, the more it will resist being pulled. Part B, when the force is increased to 30 newtons, find the resulting acceleration. So this is where we need Newton's second law, because now we're not in equilibrium anymore, but we know what the maximum frictional force is, and we assume that when you're moving, the frictional force is the maximum frictional force. In reality, this is not quite accurate, but for mechanics course, we assume that when something is being dragged, is moving or accelerating, then the frictional force that acts, if there is a frictional force, will be the maximum frictional force. And so you can use the coefficient of friction to help work that out. So in this case, the situation hasn't changed. So R is still 3G, and if we resolve horizontally, we now don't have P minus F equals 0. We have, using F equals ma, the net force, which is 30, minus the frictional force, which we know is 2.4 G. We found that out earlier as being the maximum frictional force. That's going to be equal to ma. And the mass of this block is 3 kilograms. And so we have 30 minus 2.4 G. That is your force. Okay, your net force equals your mass times your net acceleration, if you like, your acceleration. So the acceleration is going to be 30 minus 2.4 G over 3. And so it's going to accelerate at 2.16 meters per second squared. Okay. So make sure you're good at that. These are very basic skills. Equilibrium. So now we're on a slope. A block of mass 4 kilograms lies in equilibrium. So forces are all balanced on a slope inclined at 35 degrees to the horizontal and is on the point of slipping. So we're in limiting equilibrium again. Point of slipping down the slope. So draw a diagram of the forces acting on the slope. So because it's in contact, there's a normal contact force. Because it has a mass, there will be a weight, and the weight is given by F equals ma. So m is 4, and a is g. So the weight of the block is 4g. And then because it's on the point of slipping, there's a frictional force. Imagine that you didn't have a frictional force. Which way would this block slide? It would slide downwards. So the frictional force acts to resist that, parallel to the line of contact. So the frictional force acts up the slope, and it's a magnitude equal to mu n, because it's actually sliding, and so the force is maximal. Okay, so there's your force diagram. And it's quite useful sometimes to draw the angle in the next force diagram to be able to resolve. But this is the starting point. Find the coefficient of friction mu between the block and the slope. So if it's in limiting equilibrium, so it's not actually going down the slope, but it's about to go down the slope, then the frictional force is mu n. And from the information that's here, we can actually work out what mu is. How do we do that? Well, if we resolve perpendicular to the plane, we have n, and then the frictional force doesn't have a component perpendicular to the plane because it's 90 degrees to it, but the weight does. And if we work out the component of the weight perpendicular to the slope, that angle here you need to be able to work out is 35 degrees. And so the component of the weight perpendicular to the slope is 4g 4g cos 35, this line here. And so perpendicular to the slope, we have n minus 4g cos 35, and because it's in equilibrium, equals to 0. So the normal contact force is 4g cos 35. That's the first bit of information. Now, if we resolve up the slope and parallel to the slope, we get mu n. N doesn't have a component parallel to the slope, but again, the 4g does. And the 4g resolved parallel to the slope, because perpendicular to the slope was 4g cos 35, parallel to the slope will be 4g sine 35. So now we have that mu n minus 4g sine 35, that should be equals to 0, also equals 0. And so that means that mu n equals 4g sine 35. And it equals 0, of course, because we're in equilibrium. Now, if you take equation B and divide it by equation A, you get the g's cancelling. You get sine 35 over cos 35 is tan 35, and you magically get that mu equals tan of 35. which is 0.7. Okay. Now this is quite a good example to remember, because if you have an object and you only have the contact force and you only have its weight and the frictional force, and you don't have any other forces acting, then the angle here, 30, when it's about to slip, is called the angle of friction. And that's because if you take tan of the angle of friction, you get the coefficient of friction. So a good way of working out the coefficient of friction in practice is to increase the slope until your object is about to slide, work out the angle, take tan of the angle, and that will tell you what the coefficient of friction is. Okay. Part C. A force P is now applied on the block parallel to the slope, so the block is about to slip up the slope. Find the magnitude and direction of force P. Okay, so first of all, P is up the slope, because and friction is down the slope to resist it, because the force P is applied parallel to the slope, so it's about to slip up the slope. Well, it wouldn't be about to slip up the slope if you're pushing down, so P has to be up the slope. And if we're on the point of slipping, just about to slip, so we're in limiting equilibrium, that means we're just about to slip up the slope. That means the frictional force must be down the slope. And because we're about to slip, it must be maximal. Okay, now we can resolve, and from that we can work out P. So resolving perpendicular to the slope, the only two forces that have components are N and the weight. The P, by the way, if you were acting any other direction, like horizontally, etc., would affect this. But in this case, the N is going to be the same as it was in part B. It's going to be 4g cos 35. Resolving parallel to the slope, we have P, we have minus the frictional force, and we have the weight component and the slope as well. And again, because it's in equilibrium, this needs to be equal to 0. And so the P equals mu n plus 4g sine 35. And so now if you substitute for n from the first equation into the second equation, you can work out what P is. And P has to be 45 newtons for this to be on the point of slipping up the slope. Okay, it's question 4. So this is dynamics. There was a bit of dynamics in the earlier questions, but this is dynamics. In other words, we have acceleration. A 2 kilogram block is pulled along the ground by a force at an angle of 30 degrees above the horizontal of magnitude 18 newtons. The coefficient of friction between the block and the ground is 0.5. Find the normal contact force R and the frictional force F. Okay, so this is accelerating. So we're going to use Newton's second law, but it's accelerating horizontally. So vertically, there's no acceleration. And that means we can resolve vertically and use the fact that the net force is 0. So the forces acting vertically are R. There's the 18 Newton force, and its component vertically is going to be 18 sine 30. And then there's the weight force, which is acting downwards. So the net force is going to be 0. And from that, we can get that R equals 2g minus 9, because sine of 30 is a half, which is about 10.6 newtons. And so the frictional force, because we know the coefficient of friction is 0.5, is going to be half of that, which is going to be about 5.3 newtons. And now if you want to work out the acceleration, now we use Newton's second law horizontally, F equals ma, and F is the net force horizontally. So if we resolve horizontally, the 18 Newton force component in the horizontal direction is 18 cos 30. The frictional force we know is 0.5 2g minus 9. And so the net force is going to be this, and that's going to be equal to ma. The mass of the block is 2, and then the A is unknown, but we can get A by working at the left-hand side and dividing by 2, which gives us 5.1 meters per second squared. I hope that was useful.